Good morning. It's now 10:14, uh, and I'm at the LaGuardia Airport, Courtyard Marriott. That is the Courtyard Marriott at the LaGuardia International Airport. Some people say it's international, some say it's national, right? LaGuardia. And I just went through demonstrating the Thevenin's theorem, the Thevenin's resistance, and the Thevenin's voltage. And I promise us to continue with the 5 by 12 general matrix, the partial matrix determinant, and its multidimensional application. Now, those of you who have been following my series of short lectures on this 5 by 12 matrix must at this time be acquainted far enough to understand some of the abridgment that I will be making. As usual, my name is Dolphy Alexander Gilpin. I've discovered this matrix. I worked on it since 1985 in Schilling's laboratory and fully developed it, the matrix, to generate multidimensional application with series of sands output, as I describe it. Endless possibilities, another description of the output. Exponential, endless, series like sand is the most general, and SLS and DLS output. All right, so here is now the general matrix, and ABC in uppercase, and ABCDEFGH in lowercase, and the B, and we know that the B is the mid of the ABC description here, the uppercase ABC. And if you count the number of characters, you will get 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So in some of my lectures, you hear me saying 5 by 11 plus 1, and the 1 is a bit isolated from the main core of the 5 by 11. So it's a 5 by 12, and the B, DEF, IJKLMNOP, and E as the 12th character. And we note again that E is the mid of the DEF uppercase. GHI, QRSTUVXX, and once again the H is the mid of the 3 uppercase description. JKL, the K is the mid, and that's the 12th. MNO, and we note also that as of here, I started was to give Greek lowercase alphabet, and that's only because I ran out of the English alphabet. I've already used up all 26 letters in the lowercase, and so I say alpha, beta, gamma, delta, pi, omega, and pi. And MNO, I just put in some Hebrew, Aleph, I'm not too good at the Hebrew, Bet, probably Dalet, Yod, Yu, A, Va, and I think that's one is Kaf, K-O-P-H. And you could get these from the scriptures. Back in Psalms, one of those Psalms there, you see all of these Hebrew alphabet being, and with some verses of scripture aligned to it. That's where I learned my Hebrew from, because this matrix also has a religious or evangelical property to it. So let me just go briefly into it. That you notice here that it's a 5 by 11 or 5 by 12, and it's correlated with now with the 5 barley loaves and 2 fishes and 12 surpluses in Jesus' miracle. From 5 barley loaves, 5 cereal loaves, barley is a cereal, and 2 fishes and 12 surpluses. That was the main core of his miracle. He used 5 barley loaves, 2 fishes, and he fed 5,000 people, and with a surplus of 12 baskets. Here am I generating not 5,000, but 5,000 times 5,000 times 5,000, endless possibilities of 1 by 11 cereals. This is a different cereal now. That cereal was edible, and this one is numerical serials, but we can convert it so that it becomes edible serials as well. So that's that. And here I put in the specific matrix, putting in some numericals, and I randomly assign some digit to the A, B, C, D, E, F, G, H, 37962041 randomly. In this case, I and J are equal. I is equal to J. So it's 11659720. And GHI, QRST, and in this case, S and T are equal 722779564. I randomly made up this from my mind and assigned random digits, arbitrarily random digits, and MNO. Whatever letters we choose from this, it could be not consecutive ABC, but could be AMN. And if it was AMN, this one would be M, because M is the mid of the A, M, and N. And likewise, this could have been MD, MDL, and if that was MDL, then the mid, this would be a D. You know, the methodology, we get into a little bit of the methodology now. And first we choose the ABC as an operator, and we break down this into now 1, 2, 3, 4, 4 by 4. If you're working indoors, and we call that fishing by 2. We're not working singular with singular number, we're working indoors in pairs, 11, 65, 97, 20, 22 there. So if we're working indoors, this is a 4 by 4 now. 1, 2, 3, 4, and 1, 2, 3, 4. Or it would have been a 4 by 8 if you count the columns, singular columns. Going this way, this would be rows, and this way would be columns. So it would be ABC, and we get this. If we use this, because we're using the numbers here now. And then we get this remaining matrix, 1165972. And when we use DEF, we get this. GHI, we get this. JKL, we get this, and this. Now the other step was to break this down into a further ABC like 11, and we get now a 3 by 3. ABC 11 into 77, 95, 64, 74, 29, 97, and so on. That's his work, still working indoors. And likewise, here's it, but I doubt, maybe the video camera pick it up. ABC 11, and this is the matrix. So we are operating now with ABC and 11, and our purpose is to, in the end, generate back something in the configuration of this, but a unique, a different one. ABC 11, and this was the remaining. Likewise, ABC 22, and we get that. ABC 00, where's that one? 20 must be there. ABC 00. We use 00 here, and this is the remaining matrix in the methodology, and so on. But like I said, the purpose is to, in the end, generate some 1 by 11s of this configuration, unique. And later on, you'll come to find out how they are applied. When I leave them in this configuration, I apply them to chemistry and pharmacology. When it is remain with the A, B, and the C at the end, it's the monetary or economics configuration, and you see that the serial numbers on the monetary bills are in that configuration. It would be like an A, B, C at the end, A, B, C at the end. Here, the B would be the same. It would be an isolated B with some subscript or superscript. Now I'm going over this very quickly, and I'm thinking that I'm speaking to a mature audience that is acquainted with the partial matrix determinant methodology, and not just some newly people. Some new people, it would be a little bit ambiguous or are not too clear to you at this point. So we have come to this point, the ABC 11. And I promise you that because I'm very experienced, I only work up, up until this step, and then I start to generate the unique 1 by 11s with different numericals. So I'm going to try to get to just do some unique derivations from this step. And the rest of the step is for those who are inexperienced, really. When you break it down into a further ABC 95, 11 before you actually generate the final outputs. So I'm going to take a break, and then when I come back, I'm going to, from this step, generate the final output, 1 by 11s, and the extra one, which is isolated, which make it a 12. But note, there might be other people who could, from this step, generate the unique ones. I can only do it when I do the arithmetic progression of these. Like this will be A, B, C, A, B, C, D, E, F, G, H. And then the other one will be A, B, C, A, B, C, D, E, F, G, F, G, H, I. And A, B, C, A, B, C, D, E, F, G, H, J, and so on coming down the line. But others could, without any ambiguity or without any making mistakes, generate the final output just looking at this matrix. Well, I am not that skillful in doing it. I have to work to this step and generate my final output. Others, yes, have to work to another step and produce an ABC 7711 with another sub matrix, and before they could generate the final output. So I'm going to take a break here, and then I'm going to project some of these here, and from these generate the final output. And we'll see what happens from there.